Hello, we're students from Brigham Young University. I'm Garner, and we're here to introduce our Earthquake Hazard Mapper. This is a program or a script developed in Python and designed to be used with ArcMap. The problem is, during earthquakes, severe damage is caused to structures, and this results in the loss of life. One way to minimize this damage and save lives is to construct in areas that are less hazardous. Our objective is to find these less hazardous areas. We'll do this by finding places that have high probabilities of earthquakes and also have a high degree of slope. Doing this will determine what's shaken during an earthquake. We'll use two sets of data. First, DEM elevation data from utah.gov GIS, and the second is earthquake data from USGS.
So the first set of data we're going to download is Shakin data from the USGS website. Now this data has longitude and latitude coordinates for all the earthquakes that have happened around the United States that have been reported. The area we're interested in is Utah, and we're going to look at the years from 2010 to 2014. So if you go to the archives, then you can select Utah. If you look to the right over the networks, we've got Utah selected and we've got the year in 2014. So down here in the display, you can just click on each set of, or whatever earthquake you want to download. So we're just going to click on a random one to show you what to do. You go to downloads, and what we're looking for is under the raw grids, we want the text X, Y, and Z values. So we'll go ahead and download that and extract it. And then once we've got it extracted, we're going to open it up in Excel and alter it a little bit so it fits in our code, our Python code that we wrote, our script. So here we've got our Excel spreadsheet open. We're going to go ahead and open the file we just downloaded and extracted. Now since the file is not an Excel type, it's going to ask us to how we want the data delineated. So we're going to select delineated, and we're going to hit next. And we want it delineated according to spaces. That'll give us everything in the right columns and rows. So once we're here, the first thing we want to do is find the date and make sure we want to save the file as that date. So we've got November 10th, 2014. So we're going to go ahead and save the file as that date. It's important we save it as a specific date. So we're going to call that in our Python script and give that title. And the two numbers on the left we're putting in there are just placeholders to keep everything in order. So now that we've got it saved and deleted that first row of data, we're going to want to delete rows D and E. And the first column we're going to call longitude, long, and then the next one latitude. And this last column we're going to name I. That column contains the peak ground acceleration recorded for that earthquake. And once that's all set up, you're good to go. It's in the right format for the script. Alright, now that we've downloaded our earthquake data, we're going to show you where to look for and download the EM data. So if you can Google search Utah ArcMap or GIS if one works. You're going to hit Utah Mapping Portal. Once you're there, on the top there's a data tab. You can hit that, and then what we're looking for is under popular data sets, and we're on the elevation and terrain data. You can choose from any one of these. Every type should work in the script. The one we used was the NAD data for all of Utah, and we just downloaded that. You can use 10 meter, 30 meter. We use the 30 meter, so the choice is yours. Now here you could download by county if you wanted, or they should have an option to download the whole state.
Now that we've downloaded our DEM data and modified and downloaded our earthquake data, we can run our script. First, you need to open the template map, and on the right side under catalog, underneath the toolbox, you should see earthquake hazard mapping script. If you double click on that, it'll bring up the parameters required for the script. Our script requires that the user define 5 parameters. The first is the elevation data that we downloaded. The second is a workspace. This could be a geodatabase or another folder. The third is a folder that contains the modified earthquake data. We're going to use a simplified version of the data that we used to create our main atlas to save you some time. The fourth is the output location, where you want your PDF to be created at. And the fifth is an optional PDF template. This could be a cover page or any other PDF you want to append your maps to. Once you've selected those 5 parameters, you can go ahead and hit OK, and the script will start running. Currently, this script is extracting the slope from the elevation data. So our script is going to read how many files are in our quake data folder, and it's going to start processing them. So here you can see what file it's processing and what number it is of the total files. If we come here to our output path, you can see that our script has created an earthquake hazard atlas. And in a minute, there will show up a PDF of this file that's being processed now, and it's going to append that to this earthquake hazard map atlas. You can see it's created this PDF, it's changed the map here, now it's going to append it to the earthquake hazard atlas. Once it's been appended, our script deletes the old PDF. Now that our script has been completed, we can open up the output path, and there's a PDF entitled Earthquake Hazard Atlas. If you open that up, it contains our cover page or PDF template and the appended maps. Now that you have an idea of how our script runs, we're going to talk about and show you the code that we use to write this script.
I'm Ryan Moore. I'm the other student who is working on this project, and this is the code for our script. It imports the modules, then it imports all of the data we entered in the form, checks out Spatial Analyst, and sets up our initial variables. Then it runs through all of the functions and starts the main script. First thing it does is tells the user that it's extracting slopes from the NED, pops up here, runs slope, takes 5 minutes, pops right back down, and lists the directory. Then it takes the number of files in the directory and saves them as a variable and prints that it found however many files y'all have. Then it checks if the user specified a template file. If they did, then it will append it to the first page of the atlas. If they didn't, it'll tell them they didn't have one, and it won't specify it. It won't append it. Then it begins the loop. For every single file in it, in the folder, it'll check if it's a directory and if it ends in XLSX, Excel file. If it does, it'll count it, and go run the script. If it doesn't, it'll skip it. Once it enters the loop, the script will tell the user what map they are currently processing and what its number is, so they have an idea how far is left. And more importantly, so that if there is an error, it can tell them which ones it didn't print, so they know which ones to go back and see what's wrong with them. But once it does that, it processes the file name so that ArcMap can actually understand it, and then it extracts the date from the file name. Once it does that, it'll run the risk mapping function. That's located up here, and that just takes the file, converts the Excel file to a table, pulls the XY data and the acceleration from it, interpolates the data using the K-ring method, and then multiplies the K-ring interpolation by the slope. Once that's done, it reclassifies it using this fixed reclassification data. Then the script waits for a little bit because ArcMap's like that and needs time to process. Then it drops back down, and the very next thing is the alter map function. Pop right back up here, and this is where it actually changes your map and gets it ready so that it can save it as a PDF. It replaces the data source, it refreshes the data, enters the title as the date, and updates the page number, refreshes, and then it zooms into your area. Then it zooms out 10% so that you can see the entire boundary. Once that completes, the script will then save it as a PDF file. First it saves it as a temporary file, and then it will append that temporary file into your main atlas. Following that, it'll close the atlas, delete the temporary file, reopen the atlas for the next one, and then it'll increment the counter, tell you it successfully completed this map, and move on to the next one. Then the script will loop through for every file in your folder, and once it finishes, it saves and closes, and you will have your earthquake risk map atlas in the folder you specified in the form.
Right, now that you've seen our code, we want to show you our final product. We just ran our script on earthquakes in Utah through 2010 through 2014. As you can see, it took an hour and 13 minutes, which is quite a long time, but it's a lot faster than if we had to manipulate each map by hand. So if we go to our output location, we've got this file here, Earthquake Hazard Atlas. And this contains all the maps that were created from running our script. As you can see here, we have our cover sheet that has a little bit of information about what's in this atlas, and we have 55 maps that were created for Utah. Each map has a legend, has a hazard level, color-coded hazard level from very low to very high, and each area has an extents view, so you can kind of have an idea where these earthquakes occurred. So by using Python, you can see that we're able to create some good-looking maps quickly, and that we're able to accomplish our task by finding hazardous areas efficiently. We want to thank you for watching this movie, and have a great day.